All right, this is specific to 6.2 for my transitions to college math class because I am out with textbook adoption today, so I have a sub. So watch this video, watch all of it. Hopefully most of this is going to be review for you, but I don't know how long it's been since you've done this. This is a skill you learn in an Algebra 1 class. You see it again in Algebra 2A, and then it's part of our transition to College Math B. So this is 6.2, multiplying polynomials. All right, so I'm going to show you a couple of different methods. I'm going to show you a couple of different examples. The first is monomial times polynomial. If you're not taking my transitions class, you can still use this to remind yourself how to multiply. I'm going to show you distribution, and I'm going to show you box method, and I'm going to show you FOIL. So with this one, the best method is generally distribution. You can, if you want to, use box method. If you use box method, it's about the same as distribution. You're going to get the same answer. Some people like box method because they like the format better, so I'll show you both ways. So here's the example. The example is 2k squared, so that's our monomial, which is a one term, times the polynomial 6k squared plus 5k minus 3. All right, so for most people, the way that you've seen this before is through distribution. So what you do is you take and you multiply first this outside term times the first term. You take like times like, so whole number times whole number. 2 times 6 is 12. And then k squared times k squared. Those two add, which gives you k to the fourth. Then you go ahead and you distribute to the next term. 2 times positive 5 is positive 10. This k, remember, has a little invisible 1 on it. So you go ahead and when you add, you'll take k to the second and k to the first. When you multiply them, the powers add. So 2 plus 1 is 3. All right, and then the very last one, even though this one has no k, you'll still multiply. You'll take 2 times negative 3, which is negative 6. And then the k squared doesn't have anything to multiply with, so it just comes along for the ride. Now, if you don't like distribution method, or you find that it's messy, or you worry that you're going to lose pieces, you could always do this with box method. This is a 1 by 3. So when I do box method, what I'm going to do is I'm going to have, you can do this 2 different directions, but I'm going to do it vertically or horizontally. Sorry, it's been a long day. I'm going to take this 2k squared on the outside, and then I'm going to break it into 3 boxes and put the 6k squared, the positive 5k, and the minus 3 on top. And then it's like an old-fashioned multiplication table where you're going to multiply in. If you watch this video and there are questions that you still have in my transitions class, we will talk about this on Wednesday, and I'll go over anything that you have questions on. Okay, so 2 times 6 is still 12. K squared times k squared is k to the fourth. 2 times 5 is 10, positive. And then k squared times k still has that little to the first. Gives me k to the third. 2 times negative 3 is negative 6. And the k squared comes along. So you'll notice the answer is still the same. They're just 2 different methods for the same thing. I personally don't care which method you like best. You use the method that works best for you. At this point, you've taken a lot of math. So if you like distribution, use distribution. If you like box method, use box method. If you have another method that you've learned that works just as well for you and gives you the same answer, whatever. It's whatever works best for you. All right. I recommend you pause at this point and you write this down if you need it. Okay. It's always good to have things like this in your notes, although you can refer back to the video, but that way you have it as a reference for later. All right, and I'm going to erase it because now we're going to talk about polynomial times polynomial. All right, polynomial times polynomial. This is one where I really, really recommend box method, although you can use whatever you like. The reason that I recommend box method is because this is going to be something larger than a FOIL problem, which I'll talk about FOIL next. But you can't FOIL anything bigger than a 2 by 2, right? When you have FOIL, you get a 2 by 2. You do first, inner, outer, last. When you get something bigger than that, you can't do FOIL anymore. So I always recommend box method. But if you love distribution, you can use, they call it double distribution, although this one is kind of a triple distribution, and you can do it that method if you like as well. So this would be something like 2x minus 3 times x squared plus 7x plus 4. I'm going to show this first with box method because I think it's the cleaner method. I will then show it quickly with distribution because if you're a distribution person, you probably don't necessarily need to do a whole lot of review with this. Okay, this is now a 2 by 3, so when I make my box, I make it taller, I make it 2 rows, and then I'm going to make it 3 columns. That tells me I'm going to get 6 terms out of this, and I'll probably have some like terms. All right, so what we looked at Monday was the idea of adding and subtracting like. What will happen here is I'm going to multiply, and then I'm going to go back and add subtract like. You can set the box up this direction if you like. That will also work. Notice it's still a 2 by 3. This time it's technically a 3 by 2, but you still get the 6 boxes. I visually am more of a horizontal person, so I always set mine up this way. But if you're a vertical person, this will work just as well, and you'll get the same answer. Now what I'm going to have to do is I'm going to have to multiply the first term times everything, and then the second term times everything. You would do the exact same thing with the distribution. You just wouldn't bother putting a box, right? So you'd go, okay, 2x times x squared times 7x times plus 4. I don't like distribution as much, and I don't recommend it as highly just because it's easier to lose pieces and make mistakes. Whereas box method, it's not complicated, it just kind of keeps it organized. It doesn't do anything different. All right, this is an invisible 1. If you need the invisible powers, make sure you put the invisible powers on. If you don't need them, don't bother. All right, I have 2 times 1 is 2. X to the first times x squared is x to the third. 2 times 7 is positive 14. X to the first and x to the first is x to the second. 2 times 4 is 8, and the x comes along for the ride. You can put the 1 there again if you want. You can leave it off. It still means the same thing. Negative 3 times 1 is negative 3. X to the second comes along for the ride. Negative 3 times 7 is negative 21. X comes along for the ride because it doesn't have anything to multiply by. And then negative 3 times 4 is negative 12. Now, here's the other reason I like box method. It doesn't work in all cases, but in most cases, what will happen is you'll get like along these diagonals. So what will happen is, as you go to write your answer, you'll have like here and here, so you can combine them as you pull them out of the problem. 2x to the third is biggest, so it comes first. 14x squared minus 3x squared is 11x squared. Negative 21 plus 8 is the same as subtraction, and then the 21 gets to keep its sign. Let's see, that would give me 13, I believe. And let me double check myself because it's late right now and I'm tired and my math doesn't always work. So 13, 14, 15, 16, 17, 18, 19, 20, 21. All right. And then the minus 12. And that would be my answer. Now, like I said, you will get the exact same answer if you distribute. So if you like distribution, do that. I just recommend box method for multiplying like this because you'll always keep your pieces in an organized fashion. All right, so this is polynomial times polynomial. The next one I'm going to show you is FOIL. FOIL is a way to distribute when it's in a 2 by 2. My guess would be most people have seen this already. I will also show this to you in box method just so you can see it, a 2 by 2 in box method. Personally, when I'm multiplying FOIL, I multiply by FOIL because I do it faster, because when I was in high school, that's how they taught it. But I like box method because it works in any case. So to me, FOIL is frustrating because it doesn't work in every situation. So we're going to do a FOIL problem with box. So FOIL and box, same problem, maybe 2 problems, doesn't matter, I'll tell you about that. And then we'll talk about special forms. I'm keeping this really, hopefully short-ish, and I'm going quickly because, like I said, for most of you, you've seen this, and if you haven't, I'll be back in class on Wednesday, and we'll really go over it then. All right, so this is like it's kind of an introduction to this. The assignment won't be on this specifically, but I would guess that quite a few of you can already do this because it is a skill you've seen before. You might have specific questions, you might have things you struggle with, and we'll work with all of that when I'm back in class. Okay, I said I was going to distribute that one. I lied. I'm not going to distribute that one. All right, but I will show you FOIL. So this is FOIL. This is when you have a binomial times a binomial. And I'm also going to do box with this because I want you to see that you can use either method. So if you are a person that struggles with FOIL, you might like box better. If you're fast with FOIL, you will not like box and don't use it. All right, so for example, let's multiply something fairly straightforward like x plus 6 and x plus 4. If you were doing this with FOIL, FOIL stands for first, outer or outside, inner or inside, and last. Oh man, my fourth color doesn't work. All right. Okay. First means the first two terms in each, or the first term in each parenthesis. So this would be my first, and this would be my first. All right, so x to the first times x to the first is x squared. Outer means the two that are on the furthest outside edges. So this one is a first and it's an outer, and this one is an outer. Okay, x times 4 is 4x. Okay, then inner are the two that are closest together. So this is an I, and this one is an I. Okay, we get 6 times x, which is 6x. And then L are the last two in the parenthesis, and that's 6 times 4, which is 24. Okay. It generally ends up where the middle two terms, the outer and the inner, will add together. And if you remember in factoring, which we'll talk about in our next chapter, there's a relationship, obviously, between this 24 and this 4 and this 6. To finish the problem, then, you just go ahead and you combine the like terms, which are 4x plus 6x, which is 10x. If that was too fast or there are things you're not sure about, all right, you can always comment below. Okay, and then, like I said, we'll go over it in class. So if there's something you're not sure about, that's great, and we'll talk about it. Let's do the same thing with box, just so you can see it's the same process. It just organizes the math a little different. Eureka does a version of it they call tabular or something, and they do it the opposite direction that I do. I mean, if you know tabular and you like it that way, then go ahead. With box, it doesn't matter which one you put where. So you can put the x plus 4 here or here. You can put the x plus 6 here or here. Okay, x times x is x squared, x times 6 is 6x, 4 times x is 4x. Notice I'm really careful about putting my signs in. That's really important because if you forget a sign or you leave a sign out, you'll end up possibly combining incorrectly, and you want to make sure that you always combine your like correctly, right? If one of those was negative, you wouldn't get 10x, and that would make a very different answer. Okay, but like I said, if you're very quick with FOIL, I wouldn't bother doing a box method with these. However, if you find that FOIL is a struggle for you, or it's just not something you like very much, or you've learned box before, then use box method. If you have another method you like, use that. Okay, so binomial times binomial, FOIL. The last thing that I'm going to talk about in this particular video, and then we'll review this again, like I said, in class, is the special forms. There are 3 special forms. So much paper. All right. All right, there is the difference of squares. This, to me, is the only one that's really important to remember, but I'm going to show you all 3 of them. Difference of squares is when you multiply 2 pieces that look the same, but one is positive and one is negative. And what happens is you end up getting a squared minus b squared, because you get a squared plus ab minus ab minus b squared, and these equal 0. Okay? And we'll do actual problems, so not just this AB stuff. The next 2 are called perfect squares. Okay. I don't generally recommend that people bother memorizing these unless you really like memorizing things, because you can multiply them and not know the pattern. This one is more important for going backwards, but I think it's of the three, it's the most important to know. So they're called perfect squares because they're generally written like this. Please be careful. You cannot just carry this squared in. This expands to a plus b times a plus b, which gives you a squared plus 2ab plus b squared. This one expands to a minus b times a minus b, which gives you a squared minus 2ab plus b squared. To me, the biggest thing with these is not carrying the power in. We call that illegal FOIL. You can't do that. And then just remembering that this really means you have two of them, so you're going to get like a full trinomial answer. But like I said, I wouldn't bother memorizing those particular patterns because you can multiply fine without knowing them. The only reason I recommend knowing the difference of squares pattern is because this is a pattern that will help you when we get to factoring. Okay? So hopefully between each of these things you're pausing and writing down anything that you think is important. You don't have to write everything down, but anything that you think you'll need later. You probably don't want to sit through this again, if you even decided to sit through it the first time. All right, but it will be up as a reference. So just a couple of quick examples of problems that follow these patterns. I think I'll do maybe 3 of them. Then this section also covers more advanced powers, and that's something we'll definitely talk about when I'm back. I'm not going to do that in video. All right, if you are a FOIL person, so what I'm going to do is I'm going to do FOIL, box, FOIL, just so you can see the different patterns. I multiply faster in FOIL by myself, so when I'm doing this, I generally FOIL. Okay, first would be z times z, which is z squared. Then I get outer, which would be negative 9z, inner, which would be positive 9z, and last, which would be negative 81. That'll give me z squared minus 81, and that's my answer. Because I recognized that it was the plus minus, I knew that the middle terms should cancel each other. Please, with this one, make sure you remember this is now 2x minus 5y times 2x minus 5y. If you distribute the squared, you will not get the full answer. I'm going to make a cute little mini square here. Let's hope that my writing will fit into it. I get 2x minus 5y times 2x minus 5y. 2x times 2x is 4x squared. 2x times negative 5 is negative 10. When you write this, you generally want to keep the variables in alphabetical order. So that'll be xy, and then another negative 10xy. This is why you end up with a double term in the middle. Negative 5 times negative 5 is positive 25y squared. Sorry that that got so small. And those are the pieces you end up with. It ends up being this one squared, and this one squared, and then 2 times 5 twice, which is 20. That's what the pattern says. But notice, I didn't need the pattern to do that multiplication. I don't even need the pattern to do this multiplication, but it's not a bad thing to know. Oh, there's so many 9s. All right, we get m squared plus 9m plus 9m plus 81, which gives us m squared plus 18m plus 81. Okay, so I know that was fast. It was a lot of information in a short amount of time. Hopefully you watched it. Okay. When I come back, we will talk more specifically about multiplication of polynomials. But for now, hopefully this was enough of an intro to remind you of how it worked. I do have another video that I filmed, oh gosh, almost a year ago now, that's multiplying binomials that goes a little slower. I also have an adding and subtracting polynomials, which is what we looked at on Monday. So if you need to look at that, go ahead and check out my YouTube. And yes, I will see you on Wednesday. Have a great rest of your day.